Okay, continuing from where we left off, I was talking about different ways of encapsulation, explaining end-to-end packet forwarding. Right, to ensure end-to-end packet forwarding, encapsulation of my packets is very important. And understanding kuti tine different types of the encapsulation. And I mentioned we talked of the Ethernet. Tine Ethernet ports, tine Ethernet links, then tine point-to-point and serial. These are for LAN, local area networks. These are for WAN. Right. So encapsulation inaitika pa Ethernet port or pa Ethernet link. It's different from encapsulation inaitika pa serial port. So understanding that difference will be very important in understanding the issue yatinoti end-to-end packet forwarding. Right. So let's say I'm trying to send information from PC1 to PC2. We're going to discuss the types of encapsulations in GetCT. Right. PC1 information yangu yaencapsulatedwa yeyo yasvika router rinori, this is R1, this is R2, let's say this is R3. Router 1 rovhura frame yangu rotarisa packet, rotarisa destination IP. Destination IP yomatchwa nezviri murouting table. Longest match yowanikwa. Then we identify what is the interface. Not exit interface. Ratinofanira kubuda naro. Definitely in this case, exit interface redo ndeiyo. Either we identify that or we identify inonzi next hop router address, which is this one. Right? Once we identify that, takufanira ku-encapsulate packet redu, ku-encapsulate packet redu the correct way. Ethernet framing ndoinoitika apa because we have a frame riri kutraversa the Ethernet link. So Ethernet framing, we know it: source MAC address, destination MAC address. How do we find the destination MAC address? ARP. ARP table yedu mune chinhu here kana musina ARP request yoitika. Everything is happening panosendwa packet. Ndosaka marota achinzi ari very intelligent, ane memory anayo. Everything is happening panosendwa. Zvese zveARP zvatiri kutaura, kucheka algorithm rinenge riri kushanda riri kuita zvese izvo. Right, racheka encapsulation yoitika. Encapsulation iri kuitika panapa ndiyo yatinoziva yemaframe ema-Ethernet frames at this point. Right, rosvika panapa parouter 2. Rasvika parouter 2, same process yoitika paprocessing. Taziva kuti tiri kuenda kupi, rakuda kuenda kuegress, rakuda kubuda. Ndo panopinda maprotocols anonzi point to point ne-high level data link control protocol. Maprotocols anongoshandiswa kuita encapsulation kana tichishandisa a-serial link. Right? So here at this level, understanding yedu ndeyekuziva kuti tine different types of layer 2 framing. Ethernet, do you familiar with? That's the one we've been using all along. But we also have PPP, point-to-point protocol, or high-level data link control protocol, which is used currently with some serial interfaces. The difference in the serial interfaces hapana MAC address. Zvapasina MAC address, ARP requesting an ARP table hapana from a serial interface. So it's a different case altogether. Right, that's it for end-to-end packet forwarding. Let's look at packet forwarding mechanisms. Right, we have 3 ways that tinokwanisa forward a packet: process switching, fast switching, Cisco Express forwarding. In these 3 ways, it's based on understanding yekuziva kuti chinonzi control plane ne data. So the data plane, let me see. Definitely data plane. Right, we have router redu rine those 2 things. Router rese, even switch. Let me say router and switch in these 2 things. yatinoti the control plane and the data plane. The control plane, the easiest way to understand what that is the software of the router. The software which is used to build up my routing table, focusing on the router specifically. Routing table yatuti ndo patinowana maroutes edu. Paunoconfigure statically, software inobva yatora information configurations ako yobva routing table. That's the software working. Dynamic ikaudzwa dynamic protocol kunze tine network iri pakati inotora information iyoyo yoisa routing table. Iwo you request show IP route or request for that information youwe oiona. That information iri control plane, which is the software of the router. Right. The data plane, the control plane is sort of the brains of the router. The data plane is the board, is the hardware. Ndo inoita forwarding yacho chaiyo. Ndo anofamba kana vari vakomana marana vanenge vari mudata plane. So the brains inoita processing yotaura kuti packet tiri kufanira kuforwarda tichishandisa chakati. Information yoendeswa mudata plane. Data plane yoita rana yoziva kuti information inofanira kubuda packet inofanira kubuda nekwakati. So we have the brains and the body, the software and the hardware. Understanding of the difference between these two makes it easier to understand the three mechanisms that here discussed as process switching, fast switching, and CEF. Right, starting with the first one, packet forwarding mechanism. So packet forwarding mechanism, what we have, brains ziri kushanda zvisingaiti. Every packet rinopinda rinotanga raendeswa kubrain, ronotariswa, ronoprocesswa, ronoonekwa kuti longest match ichi, longest match yawanikwa, then robva radzikiswa, robva raendeswa ku exit interface. Packet rechitu rikauya rinoendeswa mubrain, brain rotsvaga, roprocessa, rotsvaga longest match, rawana robva rabuda. So every packet riri kusvika rinotanga raendeswa kubrains, ronotariswa kunzi rakamira sei. The problem with process switching ndekuti brains zoshanda too much. The data plane doesn't work that much, brains dzinokwara. So you see kuti instead of focusing router tataura nezveprimary roya yepath determination forwarding, but hazvizo zvega zvainoita router rine maACL, richaconfigure QoS. That same brain ndo ichada kushandiswa for security. Pauchaconfigure security yako yese, pauchaconfigure quality yako yese, that same brains will need to be used for that. Now, if that same brain is being used to process every packet kusvika, packets mangana anosvika through the route akawandisa. So if it is being used to process packets chete, that is very inefficient. Brains need to be used for something else. So process switching ine one problem iyoyo, yekuti brain dzinenge dzirongoshanda dzotadza kushanda other responsibilities dzadzinofanira kuita. Zviroti network ichaita slow, our network performance yakadhakwa, we have high CPU usage, etc. Right, we have the second one, packet forwarding mechanism. Yeah, it's fast switching. We have fast switching. So basically with fast switching, it's sort of, let me say, in 2-3 stages. Let's say stage number 1, packet parinotanga kusendwa. Let's say this is the initial stage. Packet parinotanga kusendwa rinoendeswa kubrain. Packet ro rikazivikanwa kunzi destination IP yayo iX, robva radzikiswa, robva raendesa kuexit interface. Raendeswa kuexit interface, rinobva rastowa mucache kuti packet rakati kana exit interface yayo iri X, rinofanira kubuda nepakati. So rakuzivikanwa mucache, cache iri kumarana, iri mudata plane, iri kuboard. Right? So now the next time panouya packet rakafanana neramboya pekutanga, ruzikanwa kunzi rinofanira kufamba sei, rinofanira kubuda nekuna X, rinofanira kuprocesswa sei. Instead yekuti iende kubrain, inongoendeswa mucache, yobva yatobuda. So it means we don't have every packet kusvika kubrain. Packet kana ratombo identify exit interface, processing yacho yese yaitwa, it's stored in the cache, The next time parinouya, instead of going to the brains, rinongoenda mukashe directly. So we have the initial stage, right? Then we have stage imwe yekuti imwe ratombouya kudhara rinenge rakuendeswa via the cache. But pakauya nyowani risingazivikanwa risimo mukashe, rinoendeswawo kubrains, roprocesswa, robva raendeswa kuexit interface. Raendeswa kuexit interface, information iyoyo yobva yaiswa mukashe. So that the next time you have that same packet, same type of packet, rinongozivikanwa kunzi rikuenda sei. So this is sort of an improvement per process switching, with the initial stage of fast switching being identical to process switching because rikuenda kubrains first, but improvements obviously because tane cache, not every packet rinofana kuenda to the brains, right? This is fast switching, so obviously it reduces CPU usage nyana, but it's still not the type of forwarding inenge ichishandiswa, iri kushandiswa nowadays paroshandiswa inonzi Cisco Express Forwarding. All right, so you can see here Cisco Express Forwarding. Nambotaura nyaya yekuti understanding ye-control plane ne-data plane, very crucial. With Cisco Express Forwarding, the control plane and the data plane are independent. Zvakatosiyana. They are independent of each other. So, in short, CEF, yeah, dzanyaya dze-CCNP. CCNP, CEF, zvinofambidzana. But in short, just to give you a piece of what is happening, ndambotaura this is the software, right? Ndokune ma-tables ese, ma-routing table, ndiyo inotsvaga information yese, the brains. So what happens in CEF, the brains rinotsvaga ma-table ayo ese, ma-routing table, rotsvaga that information, yobva ya-uploader, or let me say the data plane rinodownloada information yese iyoyo. Information iyoyo inodownloadwa, you identify as these two tables, FIB, the forwarding information base, ne-adjacency table. The brains raita basa rayo, racollecta information, the hardware rinodownloada that information. Radownloada that information, panosvika packet hariende kubrain, because the hardware iri kuziva information yadownload. So ma-updates, panochinja network, brains dzino-update kuti network yachinja, zviroti download rinobva ratera reupdate kuFIB kuratidza kuti network yachinja tane zvinyowani, hardware yobva yaupdate. Pese panongosvika packet, harisisina need rekuenda the control plane, which is the brains, because the hardware iri kudownloada zvese zviriko kubrains ikoko. So the good thing about this CEF ndeyekuti you can see kuti brain hazisi kushanda that much packet forwarding. Brain ziringofunga kupa ma-routing tables, FIB, ne-adjacency table, that's it. Hardware yodownloada, yoita basa rayo yekuita rana. CPU usage yese ingari kumboendeswa kuprocessing ne-forwarding nechii, hakusisina kunoko. Therefore, in terms of performance, you see with CEF, it will perform better than the other two that ninge tinazo. Because all the packet forwarding inenge offload kunzi ende ku data plane, which is the hardware. Right. Moving on, basic router configuration review. The topology in the figure will be used for configuration and verification examples. It will be used to be used in the next topic to discuss the IP routing table. Okay, but no IP routing table, we'll deal with this. Right, here we have my commands. I think we've used Mashuro, basic router configuration review. Okay, this is a review. I think this is a review of my router configurations. We've did all this, my host name, blah, blah, blah. We've did all this, nothing new there. We've configured my interface, IPv4 and IPv6. We've configured my interface. We've configured a serial interface. Take note of this. Start understanding the difference between these things. Gigabit Ethernet, serial. What is the difference between a serial link and a Giga Ethernet link. What's the difference between that? It's high time you start identifying my answers to those questions. All right, so this is just a review, nothing new here. Let's see what it leads up to. We have verification commands, show IP interface brief. I repeat, my commands are show. They are very important. Very important in the sense that they show you kuti network yako iri kurana sei. They show you, for example, in this topic yatiri show IP route, it shows you kuti the routing table yakaita sei. Maroutes anozivikanwa nerouter yako yakaita sei. So very important to understand kuti mashow commands anoshanda sei at this point. Right? We have IP routing table, route sources. Right, we have what we call route sources. A routing table contains a list of routes to known networks. The source of this information is derived from the following. So my sources, tambotaura nenyaya ma directly connected networks, my static routes, my dynamic routing protocols. Right? So information, route source, information yekuti route yakaita sei inobva kupi. One, static, manual configuration. You can manually configure a route. That is static configuration. Then Tinema routing protocols, OSPF. The one we'll be looking at, I think, after this routing concepts lesson, OSPF. Ndokunobva mamwe ndo anonzi route sources edu. In summary, here we have them summarized. Arapa. Anenge ane macodes anoshandiswa nayo. Ukavhura routing table, ukati show IP route, you definitely see these codes, LCSO. L, identifying the address assigned to a router interface, which is a local address. So if I have a small network, continue using this network. Oh, right. This is an LAN A and LAN B. This is router 1, router 2. Ndikati some router 1, iri interface iri. Rinenge rakanzi L. Network interface iri obviously relates to network ish, LAN A. Right? Ukaritarisa routing table rinenge rakanzi AL, which means it is a local address. Rinenge rakanzi C as well, because it is a directly connected network. Interface iri rinenge rakanzi C as well, directly connected network. Right? Interface, let's see, static. We'll look at static. This is manually configured. OSPF, that's another one, dynamically configured routing protocols. Right? Let's look at routing table entries. All right, we have the root source to discuss an SRO. Let me see. Let me try to find a show IP route somewhere. I think it best explains right, show IP route. Right. Do information about show IP route issue. Right, my letters and atanga do arapa. So we have CCCS arapa. Connected, and static. Right? The next information that you discuss could discuss about the number irapa ichi. My addresses arapa. Then shall discuss a number arapa 10 chi. Then shall discuss a number irapa chi. Next hope address. Shall discuss a interface my interface arapa chi George. Right? My exit interface. So tauda identify exit interface, tauda identify kuti per routing is basically trying to read information iri pa routing table yako. How do you read information in routing table yako? What do you have? Right. So what we have is the source. Right. I think PowerPoint redirect and aware in the routing table beside so that it becomes easier. All right. So what we have, number one, we have the source. In this case is O, meaning OSPF. That's how the route was learned dynamically via the routing protocol OSPF. Next, we have the destination network. A destination network explains itself. It identifies the address of the remote network. Kurukenda packet. kufanira kuenda packet, or it might not be the destination, but probably kwarichapfuura nako. That is the destination network, right? That is the next, number 2. Ukatarisa parouting table yako, all this information inenge iripo, right? Number 3 and 4, we have the administrative distance and the metric, right? With the AD identifying the trustworthiness of the route source. Lower values indicate preferred route sources. So trustworthiness, pane mamwe maroutes hausingatrust. Let me start by saying I would trust route randaconfigure manually over route rinolenwa dynamically. So you see kuti pamanumbers ayarapa, kana route riri land statically rinenge rina, it should be 1 instead of 110. Route kana riri land via OSPF ndo rine 110. So let's say ndine 2 entries parouting table are kuenda to the same network. Imwe ine AD1, imwe ine AD100. I would definitely choose ine AD1 because of trustworthiness yayo. Kuti do I trust route randaudzwa ne information yandiri kureceive? I can definitely trust 1 randaisa statically. I can trust rine 0 directly connected. So interface router number 1, my interfaces are they're directly connected. I have to trust my directly connected networks. So you see my directly connected networks, number 3 up AD anengane value yes, because ndo ari most trustworthy. Okay, most trustworthy. Right, that is the administrative distance. Right, other I know of RIP, let me see, RIP, it should be, is it 120? You have to know these numbers. So OSPF AD that we want to air up 110. I think we have protocol RIP is 120. Data RNA directly connected, it's 0. Static, it should be 1. So my protocols esamunoziva anenge ane number iyoyi, but I think these are the ones I could get top of my head. Right, so AD, we also have the metric. This identifies the value assigned to reach the remote networks. Lower value indicates preferred route. Right, value is metric, it depends on the routing protocol. Trust my routing protocols as well. So this one is metric, it depends on my routing protocol and how they calculate my metrics out. See RIP, RIP, inoshandisa hop count, metric yayo, RIP, hop count. I'm not sure it is for this level hop count, it should be. Then we have OSPF, I think inoshandisa cost, which is the bandwidth. It looks at the bandwidth, my links could up until wasvika ku destination. So the metric value mostly inogona kufanana. You can see kuti ndikatarisa metric value RIP ne OSPF pasame destination network yandinoda kusvika angona kufanana, angonoita ma 50-50 ese. Aita ma 50-50, then pauda tiebreaker ndo rinouya AD robva rauya rati for OSPF here we have 110, 110. For RIP we have 120. Therefore this route is not preferred. This route is preferred because ndo rine lower IT. So basically that is what will be happening. The relationship between number 3 and 4 ndeyekutarisa mametrics, mahop counts, macost nekutarisa administrative distance. Right, number 5, we have the next hop, which identifies the IP address of the next router to which the packet will be forwarded. So example yangandikupa all along, in this case, if I'm trying to send from PC1 to PC2, next hop address is this address. That's the next hop address. So pauno configure network, you see pamucha configure my network statically, you need to specify kuti next hop address ichi. or you need to specify kuti exit interface ichi, which is number 7 tichasvikako. This is the exit interface, or you need to specify both. What is the exit interface? What is the next hop IP address? All right, so basically this is the next hop. So next hop inotibatsira kuziva kuti packet richapfuura nekupi. So iwe ukaisa next hop IP kuti ndeishi, tomboti tine rimwe router panapa. There is no way packet parichauya nekunoku. Richauya nepara address kwapo kunzi next hop pauri kusvika uchienda ku next router and up. Rinouya nekunoku. Haritori this direction because yaudzwa kunzi it has been specified with what is the next hop address. Right, root timestamp number 6. This identifies how much time has passed since the route was learned. So I think the significance of the root timestamp, the larger the value, time irapa, the larger the value, it means route error is not being updated. And that's a problem. You're not going to send a packet to route rakafa udara risiri kushanda because it's not being updated. Kana router riri kushanda, my routing protocols, they constantly update. After interval, they update kuti izvezvi link redu riripo, inini ndiri kuziva maroots akati. Every interval it updates. So if there is no update, zviroti this time inokura. Ikakura, zviroti root irororo harisiri kutrust, basically. Right. Lastly, we have the exit interface. I can relate it to this, the next hop. It just helps identify with the packet return and a kube. So if you specify what is the next hop, what is the exit interface, packet rasiki rinoenda kwawarudzwa kuti rinofana kuenda. Kwaraudzwa nerouter, if I can say. Right. Moving on to directly connected networks. We've talked of this. A directly connected network, code C L as well, because a directly connected network is local as well. I've touched on my directly connected networks. My static routes, I've touched on them, manually configured. 3 primary uses. It's not always pamunofana kuisa my static routes. In a very huge network, I'll pin the router which define every route, which configure every route statically. You don't do that. So what are the primary uses? The static routes provides ease of routing table maintenance in smaller networks that are not expected to grow significantly. So for small networks, static routing, use a single default route to represent a path. Kana uruda configure a default route, yatambotaura yekuti packet rashaya longest match. Without the default route, it gets dropped. Kana uruda configure default route, it's best you do it statically because you one default route or configure one. Running out of time again. Right? It routes to and from a stub network. Kana uruda configure stub network, use my static routes. Stub network chi. Network yedu yakaita something like this. Iri rinonzi stub network iri. A stub network is a network accessed by a single route and the router has only one neighbor. Right? Iri stub network iri. Because route iroro i1 chete rinosvikawo. Hapana rimwe route riri kusvika ipapo. So inonzi stub network. So interface network iri kuenda uku ishi. Static. It should be statically configured. Right. Moving on to the topology static routes. Okay, here there's demonstration and configuration static route. So we are at R1. All right. At R1 here, we're going to configure static route. This is the destination 10.04.040, which is this network. Okay, that's the destination, right? And this is the next hop, meaning is this address here. So that is a static route being configured. So tripa router panapa, router rikuudzwa kunzi pane imwe network iri kunoku ishi inonzi 10.040/24. Kana uchida kusvika kunetwork ikoko unosvika sei? Unouse this next hop address. So basically that is what you configure paunoconfigure static route. Tine network issue. Kana uruda kusvikako unosvika using this next hop address. Right. Moving on, dynamic routing protocols. We've talked about this. Same process. My routing protocols, the difference in my static. My routing protocols, protocol, my dynamic, I mean, my dynamic, my dynamic routes. Protocol ndio rinenge kushanda. Protocol ndio rinocollecta information kuti maroutes andiri kuziva as R1 and up yobva send information kuna R2, R2 yoita the same until the network yese yaita convergence, then that's it. So that's it for my dynamic routing up. The dynamic routes in the routing table, OSPF is now being used, etc., etc. Right here, we are just identifying my dynamic routes in the routing table. So you can see we identify OSPF by O. Can I do this? Which one can I use? Red, yellow. Right. We identify. Okay, this one is impossible. We identify OSPF by O. We identify RIP. Here we have RIP by R. We identify BGP by B. That's another routing protocol. We have D for EIG, RP, etc., etc. That's how you identify them per routing table. As we go, you will learn about easier ways to identify them. The default route, we've touched on that one, right? You can see default route, you can see what we're going to it always leads to the ISP. So we have router, configure router IP. Unfortunately, we don't have the configuration, but can let's a default router panel. The consult the default router rango destination network 000 via this next hop address. Irufana kuenda to the ISP here. Default router of Ashanda. So every packet rubber my networks I rikashaya match pa R1, it means rinoendeswa uko. Rover rabudiswa uko kuenda ku ISP. Right, default static, default route, we've touched on that. I got one day. Right, administrative distance, I've touched on this as well. Trustworthiness of a route. Trustworthiness of a route. So you see, my directly connected are most trusted. I stay on my static. Then after that, we have my protocols depending on the protocol EP. Right, and these are the values. Okay, static, route, R2, and are most trusted. Then after that, we have my protocols. Yadisha concentrate on and they know OSPF. We will be demonstrating use RIP, but we don't use it that much. So this is the trustworthiness CMR routes. So route 1, rakaita 2 different protocols. Protocol inochuzwa ndoinenge the least value per AD. Right, static and dynamic routing, we've defined this with the time left at 4 minutes. I'm just going to browse through this. We've defined what is a static, what is static routing. We've defined what is dynamic routing. We've mentioned with static rinoshandiswa primarily papi kana une small network, kana uda configure stub network, kana uda configure a default route, use static. But in a larger network, you definitely have to use my dynamic routing protocols. Right? So in terms of scalability, I've just seen scalability. It means my dynamic routing protocols, they are more scalable because protocol run bus. Instead, you would manually configure every router one by one. Right? My dynamic protocols, pakatika change in the network, it updates automatically. But for static, pakatika change, there is no update. You have to know kuti paitika change or change our static router or config. Right? That's a brief comparison of static versus dynamic. In terms of size, obviously, increases with the network size. Configuration complexity. Okay, configuration complexity, static is very easy for small networks, but the network ikakurisa becomes very difficult. Dynamic, independent of network size, very difficult to configure. topology changes, etc., scalability. Let me touch on. Okay, this is just a comparison. 3 minutes. Let me try to see if I can finish off. Dynamic routing evolution. I want to look at this. Right. My routing protocols edu tine two main types. Zema routing protocols. Tonight not my interior gateway, tonight not my exterior. My interior they are used for my networks edu atinoshandisa relocal. Kana wakuda kubuda mu network wakushandisa rinonzi exterior. So you see exterior rinoshandiswa I think ndiro one rinonzi BGP, border gateway protocol. Then for interior we have RIP. I think most use in our case for this course OSPF, right? So from interior IGP, EGP, we have my distance vector, my link state that differentiates in terms of my matrix. Per distance hapo, we have my hops, my link state, ndo pane ma OSPF, my matrix are my cost. Summarizing, going through these dynamic routing protocol concepts, we've defined this dynamic routing protocol concepts, data structures, routing protocol messages, algorithms. Right, data structures. My components are dynamic routing protocols. We have my data structures, which are our routing tables. Briefly, those are our routing tables. We have my protocol messages. Pese panaitika ma-updates, message inosendwa. So there's constant updates yekuti izvezvi network yakati yakamira sei, network yakati iri down. Though that's another component. And lastly, the algorithm. There's an algorithm which calculates kuti tine packet longest mechichi pane update yaitika, can we change that? So that's an algorithm rinenge rikushandira programming. That's for the programmers. Best path. Can I finish? How many do I have? Two. Last two. Best path. We've mentioned issue with the router primarily being used, or its function being determining the best path. How does it do it? Depending on my matrix. Here are our matrix at now. I think I have less than a minute. Let me just conclude. This is it for our routing concepts. We're done for the day. We're done with the routing concepts. 2 lessons, that's a lot.